Hi guys, hope you're doing well. Today we're going to talk about organic nomenclature or organic naming. So we follow the International Union of Pure and Applied Chemistry in terms of naming, and we've already learned in Chapter 9 how to use the IUPAC system for naming binary compounds, meaning that they are compounds that are made of two elements. But now we are going to look at how we name organic substances. The rules are a little bit different for organics. So before we start, I thought it would be interesting to see some names. This is the tryptophan synthetase, which is a protein. And it's actually not its whole name because this is the amino acids. You know how they have like 3-letter names, so that's with the 3-letter abbreviation, so it's kind of long. We will not be doing anything like that. I also thought it would be funny to show you some of the interesting names of some organic substances. There's moronic acid, comic acid, draculin, spamol, psychose, megaphone. So there's a lot of funny names. Organic chemists like to have fun with their naming, but these are more common names as opposed to the accurate system. So let's look at the actual IUPAC naming system. So for an organic molecule, the name actually has 3 parts to it. Just like your name has 3 parts to it. You have a first name, a middle name, and a last name. Organic molecules also have 3 parts to their name. So they have a prefix, a parent, and a suffix. So the parent tells you how many carbons are there in the main chain, in the longest chain in the molecule. You count up how many carbons and you give that a name. The suffix tells you what type of functional group it is. Is it an alkane? Is it an alkene? Is it an alcohol? And then the prefix tells you if there are other branches attached to the main chain of carbons, or if there are other interesting elements like a chlorine or a fluorine or a oxygen or something like that. So we're going to start with the parent, the kind of the middle name here first. And what you do is you find the longest chain of carbon atoms that contains the main functional group. And to do that, what you do is you kind of have to count the carbons without lifting your finger or without lifting your pen or pencil off the paper. And you count how many carbons there are. If the longest chain of carbons is only 1 carbon, that gets the name meth. 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 is oct, and 9 is non, and then 10 is dec. Now, starting with pent, those are probably names that you're familiar with. You know, everybody knows that pent means 5, hex means 6, and so on. So those are pretty easy. The first 4 are kind of hard because we're not really familiar with them as much. Meth, so a lot of people are familiar with the word meth as the drug. In reality, there are millions of organic molecules that start with meth or methyl. It's just that, the people who use the common name for the drug are not really familiar with organic chemistry, and so they just thought that that's unique to that drug. But meth is not a drug. Meth just means 1 carbon in organic chemistry, and there's lots and lots of compounds that start with meth. Anyway, eth is 2, like I said. 3 is prop. We talked about prop a lot on the last video with, we showed propane, propene, propine, propanol, and so on. But is 4. So those first 4 are a little bit hard. This is a mnemonic, but I don't think it's useful. It's kind of hard to remember the mnemonic. It's easier to remember just those, so I wouldn't use it. Anyway, so that's our parent. Let's look at the suffix next, the ending. So the ending tells you what functional group it is. So you decide which functional group it is and add the corresponding ending to the parent name. A functional group is an atom or a group of atoms that determine the characteristics and properties of the organic molecule. We kind of defined what a functional group is in our last video as well. So if it's an alkane, you end it with ane. So for example, let's go with the prop example. So if there's 3 carbons and it's an alkane, we'd call it propane. If it's an alcohol, it has an OH, then you end it with anol. So again, propanol, propanol. Alkyl means that you have a branch. So this means that you have a branch coming up from the main chain, and we'll talk about branches a little bit later. But if you have a branch, you end it with YL. It's called an alkyl group, and you end it with YL. So if it was 3 carbons, you'd say it's propyl. It's a propyl group. Alkene, that means that it has a double bond. You end it with ene, so propene, for example. Alkyne, the Y tells you it's a triple bond, so you end it with ine, so it'd be propyne. If it's an ether, you end it with the word ether. If it's an ester, you end it with the word oate. And if it's a carboxylic acid, you end it with oic acid. Now, I will not ask you to name these. I just want you to be able to look at the name and recognize what functional group it is. But for those, I will actually ask you to name them. So these are the ones that we really want to focus on in this video. Okay, so we said that we have a prefix, a parent, and a suffix. We talked about the parent and the suffix, so we'll practice some with the parent and the suffix, and then we'll come back to the prefix, because not all of them actually need a prefix. So let's practice some. So here, we are going to count how many carbons are in our main chain without lifting our finger or our pencil or pen off the paper, and that's going to give us the parent. So here we have 1, 2, 3 carbons. So that would be prop. That's the parent. And then you decide what functional group is it to give it the ending, the suffix. So in this case, we have all single bonds. We just have carbons and hydrogens. No rings or anything special, and so that would be an alkane. So you would end it with ane. So this is propane. Let's look at the next one. This one here. 1, 2, 3, 4, 5, 6, 7, 8. So 8, the parent would be oct for the 8. And then you look to decide what functional group it is. So there's no ring, there's no double or triple bond, there's no special atoms, they're just carbons and hydrogens. They're all single bonds, and so there's nothing special here, so it's just an alkane. So octane. Have you heard of octane, like octane ranking in gasoline? Octane is one of the parts in the gasoline mixture. So there's an octane rating when you fill up your gasoline. Okay, let's look at the next one. We have 1, 2, 3, 4, 5, 6, 7. So 7, the parent would be hept. And they are all single bonds. However, there is something special here. Look at this. There's an OH. What does that make it? Just an OH. Everything else is the normal single bonds, just carbons and hydrogens. OH means it's an alcohol. And so it ends with anol. So we're going to write heptanol. Now, this heptanol is a special heptanol because it differs whether your OH is here or here or here. And so we have to specify, like if I give you this name, you would know there's 7 carbons. You'd know you have an OH, but you wouldn't know where to put it. When we give the name, we need to be able to go from the name to the structure or from the structure to the name. So this is not complete because I don't know where to put that OH. So we need to put a number in the front that tells us where that alcoholic group is, where that OH is. Now there are 2 choices here. One of them is correct and one of them is not correct. you could say, okay, I'm going to number my carbons. This is going to be carbon number 1, 2, 3, 4, 5, 6, 7, and say, oh, this alcohol is coming off carbon number 6 right here. What's the other option? Well, what if I say, I'm going to start numbering from the other way. So I'm going to say this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Does it matter? The answer is yes, it does matter. One of those is correct, one of them is not. The green is correct. The yellow is not correct. The reason is, whenever we put numbers in our name, they need to be the lowest numbers possible. So we want to number our chain so that we get the lowest number possible that we can get. So if you number it using the green numbering system, you will get that the OH is on carbon number 2. But if you use the yellow, then it's going to be on carbon number 6. 2 obviously is smaller than 6, and so the green way is the correct way for numbering it. So you would want to use the green one, not the yellow one. So this would be called 2-heptanol. In our names, between a number and a letter, we put a dash. Between a letter and a letter, like the parent and the suffix or something like that, we don't leave any space. And between numbers and numbers, we put commas. We'll see that as an example later. Okay, let's do the next one. Next one, we have 1, 2 carbons. So the parent is F. And then we check what functional group it is. This is just carbons and hydrogens, no special atoms, no OHs, no no double bonds, no triple bonds, no rings. So really nothing special there. So it's an alkane, so it would be ethane. And that is it. Let's look at the next one. Next one, just one carbon. So one carbon would be meth, and so that would be our parent name. And let's see what functional group it is. I see NOH here, and that tells me it's an alcohol, so enol is the ending. So methanol. Methanol is what we use for our birthday celebrations. We pour it on the table and light it on fire. We sometimes use methanol, which looks like this. Sometimes we also use ethanol. Eth would be 2 carbons, right? So ethanol looks like this except it has an OH somewhere there. So anyway, this is methanol. Do I need to write that this is 1 methanol on carbon number 1? No, I do not, because there's only 1 carbon. What if, just for fun, what if this was NOH and I say this would be ethanol? Do I need to put that it's 1 ethanol? The answer is no, I don't. Because if I say this is carbon number 1, the ethanol would be 1 ethanol, right? So it's on carbon number 1. If the OH was, let's say, on this carbon instead, well, then in that case, you would say that this is carbon number 1. So either way, it's going to be on carbon number 1. So we really only need to number it, put a number there for an alcohol if it's 3 carbons or more, then it would matter. All right, great. Now let's do the opposite. So now we have the names, and we're going to try to come up with the structures. So let's see how we're going to do that. So this says 2-octine. So the first thing I want to look at is the parent. The parent is oct. That tells me there are 8 carbons. So I draw 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. And I connect all of them. Okay? Then I look at the ending, and it's "ine." What does that tell me? That tells me that it's a triple bond. Great. Well, there's a lot of places where I can put a triple bond, right? So then I say, oh, let me look at the front and try to figure out where that triple bond is. So it says 2-octane. That means it's on carbon number 2. So when you're drawing the structure, it does not matter where you want to number it from. If you want to number it from here, great. If you want to number it from here, great. It does not matter. You decide because you're the one who's drawing the structure. So I'm just going to say this is carbon number 1. So when it says 2-octane, that means the triple bond is on carbon number 2, right? So then, does that mean it's between 1 and 2 or between 2 and 3? Because it just tells me 2. So I know it's here, but a triple bond is between 2 carbons, right? So is it here or is it there? Well, the answer is it's right here between carbon number 2 and carbon number 3. How did I know that? Because remember, the name has the lowest number possible. And so if it was here, then I would say it's on carbon number 1, because between 1 and 2, I'd say it's carbon number 1, right? That's the lowest number. If it's between carbon number 2 and 3, then I'd name it 2, because that's the lower number. So that tells me that the triple bond is right there. Then, we're not done yet. We need to make sure that each carbon has 4 bonds. So whatever carbons don't have 4 bonds at this point, you want to add some hydrogens there. And so I'm going to go ahead and add, I need 3 hydrogens on this carbon. Carbon number 2 is already good with 4. Carbon number 3 is already good with 4. This carbon needs 2. This carbon needs 2. 2. 2. And then the last carbon here needs 3 hydrogens. Now, that's kind of long, right? So if you prefer, you can draw the stick structure. Remember, it looks like a zigzag. So you just start with a zigzag and you keep going until you've drawn 8. I'm just going to show you where they are. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then it's telling me that there's a triple bond, and the triple bond is between carbon number 2 and 3. So that means it is right here. There's carbon number 2, there's carbon number 3, so I make that a triple bond. And there it is. Let's try 3-hexanol. So hex tells me that it's 6 carbons. So 1, 2, 3, 4, 5, 6. Enol tells me it's an alcohol. So that means OH. Where do I put my OH? On carbon number 3. Again, you decide where you want to number it. You can say this is carbon number 1, 2, 3, or you can say this is carbon number 1, 2, 3. So you can put it either on this carbon or on this carbon, depending on where you're looking at. And so it would be acceptable if I put the OH here, 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 or here. You pick. Does not matter. But you just put only one OH group. So just for fun, I'll put it right here. Then you just fill it up with hydrogens. This one needs 3 hydrogens. This one needs 2. This one needs 1, 2, 2, and 3. If that's too much, you can just draw your stick structure. So that is 6 carbons. 1, 2, 3, 4, 5, 6. Off of carbon number 3, 1, 2, 3. So off of this carbon, I'm going to put an OH. So there's my bond to the OH. Let's try the next one. Next one is ethanol. So ethanol, Eth tells me it's 2 carbons. Sorry. There we go. And I'm going to draw my 2 carbons here. All, or enol, tells me it's an alcohol. Now notice it doesn't tell me what number because it does not matter. If I put my alcohol, my OH, on this carbon, then this will be carbon number 1. If I put it on this carbon, this will be carbon number 1. So either way, it does not matter. So you can actually put it anywhere here or anywhere here. So I'm going to go ahead and put it right there. Again, it would not matter where any of those 6 spots are fine. If I wanted to do the stick structure, there are my 2 carbons, and then OH. Okay, decane. So decane means I have 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does ane mean? All single bonds, just bonded to hydrogens, nothing special. So you just fill them up with hydrogens. It's a lot of hydrogens here. Make sure each of the carbons has 4 bonds. That's a lot of drawing. So here, it's really handy to use the stick structure. And there we go. That's all you do. It's just a zigzag. And you count how many. Make sure there's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, the vertices are your carbons. Last one pentanol. Pent means 5, so I'm going to draw 5 carbons. 1, 2, 3, 4, 5. The enol tells us it's an alcohol, and so we want to put an OH there. We need to know where it goes, and so it says 1 pentanol. That means it's on carbon number 1. So it's up to you if you want to call this carbon number 1. So if that was carbon number 1, you can put it here, here, or here. If you say that this is carbon number 1, then you can put it on this one. So here, here, or here. Totally up to you. Anywhere out of those 6 spots is fine. So I'm going to go ahead and put it here just for fun. Change things up. Then you fill the rest with hydrogens so that each carbon has 4 bonds. Oops. If you want to do the stick structure for this one, here are the 5 carbons. And then on this first carbon, there's an OH, so bond OH. Before we talk about the prefix, I want to briefly talk about isomers. So isomers are molecules that have the same molecular formula, but different structures. These happen a lot in organic chemistry because a lot of the molecules in organic chemistry are just carbons and hydrogens. Even if they have like an oxygen, you know, there's only a few limited types of elements that are in the molecules, and there's like 20 million organic molecules. And so a lot of them have the same formula, but they can be drawn in a different way like we've seen. So let's take a look at these 3 here. This is called butane. This is called 2-methylpropane, and this is called T-butanol, tert-butanol. 2 of these 3 are isomers of each other. Which 2 are isomers of each other? Well, even though these look very similar, they are not isomers of each other because they have different formulas. This is C4H10, this is C4H10O. Those are different, so those are not isomers of each other. However, these 2 are isomers of each other because they both have the same formula. They are both C4H10. So those are 2 different ways for drawing C4H10. They are 2 completely different molecules. They have different characteristics and so on. So those are what isomers are. All right, so let's finally get to the prefix. A prefix tells you if there is something special, like a special type of atom, like we said chlorine or something like that, or if there is a branch coming off of your main chain. So for this year, we're just going to look at branches. So if you have a branch, we call those substituents. Those are branches. And we also call them alkyl groups. So alkyl groups are branches or substituents that come off of the parent chain, the main chain. So the way that you would name that, if you have a branch coming off, first you would identify the number of the carbon to which the branch is attached. So on the main chain, which carbon on the main chain has the branch coming off of it? So you write that number down and then follow that by a dash. Then you count the number of carbons in the branch and assign its name. So the branch itself, count how many carbons there are. If it's a 2-carbon branch, for example, then you do F. If it's 1, meth. If it's 3, prop, and so on. Then you follow that by YL. So if the branch is 1 carbon, you call it methyl. If the branch is 2 carbons, you call it ethyl. If it's 3, you call it propyl, and so on. If you have 2 or more, that should say of, the same branch, the number of them is indicated by di, tri, tetra, penta, and so on. So if I have 2 methyl groups, I'd say dimethyl. If I have 3 ethyl groups, I'd say triethyl, and so on. And lastly, if the branches are different, you put them in alphabetical order. So ethyl comes before methyl, which comes before propyl, because E comes before M before P in the alphabet. So let's look at some examples and try to name them. So first thing, let's look at this one. We are going to try to find the longest chain first. So to find the longest chain, you put your finger or pencil or pen on the paper and you go through and see if you can find the longest chain. So let's look at the different possibilities. I could go just straight across. I could go make an L, so from the top down to the side. Or I could make this L, backward L. Now one of those is acceptable, the other ones are not. The one that's acceptable is the one that's going to give you the longest chain of carbons. So let's see, if I go straight across 1, 2, 3, 4, 5, 6, 7, 8 carbons. If I do this L, I get 1, 2, 3, 4. If I go down this way, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it seems like this way is the longest. Once you find your longest chain, circle it or box it or something. There we go. And then what you do is you name them. So there are 9 carbons, and so we call that non. And it is just an alkane because they're all single bonds, all just carbons and hydrogens, nothing special, so nonane. Now by saying nonane, we have named everything that's in that yellow box. So what's left? What's left is this right here is not in the box. We need to name it. That is a branch coming off of the main chain. So what we do is we figure out which carbon on the main chain is the branch attached. So we can number it by starting from here, as this is carbon number 1, or we can start from here. Which method is better or correct? Start from here, because if we start from here, you go 1, 2, 3, it'll be carbon number 3 that the branch is attached to. If I started here, I'd go 1, 2, 3, 4, 5, 6, 7. It'll be on carbon number 7. So 3 is much better than 7, and so I should have numbered this as 1, 2, 3, 4, 5, 6, 7, 8, 9. So my branch is coming off of number 3. So I put 3 dash, and then I count how many carbons are in my branch. There's just 1. So 1 would be meth, but it's a branch, so I end it with YL. So my branch is a methyl, and it's coming off of carbon number 3 from the main chain. So now you put the whole thing together. So if I name this whole thing, this is called 3-methyl nonane. All right, let's try the next one. Here it is. So let's see what the best way is. I can go straight across. I can make this L. I can make a U. I can make this L. I can make this backward L. I can make this backward L. All kinds of different possibilities. What's the best way? The best way is you either go straight across. That's going to give you 1, 2, 3, 4, 5, 6, 7. Or you could go this L. 1, 2, 3, 4, 5, 6, 7. If both methods give you the same number of carbons, that means whichever way you pick is going to give you the same name. Don't worry about it. Pick one. I'm going to go, just because it's easier, I'm going to say straight across is my main chain because it's just easier for me to see it. I'm going to say that's my main chain. And we said there's 7 in there, so that's hept. And again, it's an alkane, nothing special in it. So heptane. So by writing heptane, we've named everything that's inside of my oval there. So now what's left? Ooh, it looks like I have 2 branches, one right here and one right there. So first, I need to figure out to which carbon on the main chain are the branches attached. So which way should I number it? Should I start from here as carbon number 1 or from here as carbon number 1? Well, you want to start from here so that your branches are coming off of 2 and 5 as opposed to 3 and 6. So let me number my big chain. 1, 2, 3, 4, 5, 6, 7. So I have a branch coming off of carbon number 2 and a branch coming off of number 5. There's 1 and there's 1. Let's start with number 2. So I'm going to say I have 2 dash, and then I count, oh, there's just 1 carbon there, so meth. And it's a branch, so I call it methyl. Okay, got this one done. All I have left is this one. This is off of carbon number 5, so 5. And it's only 1 carbon again, so another methyl. So now let's put the whole name all together. So I have 2 methyl groups, one on carbon number 2, one on carbon number 5. So if I have 2 of the same type of group, I write both numbers. So I'm going to write it up here. So I'm going to say 2, 5 dash di methyl and then heptane. So what this is telling me is I have a long chain that's 7 carbons all singly bonded. It's an alkane. And on this chain of 7, on carbon number 2, I have a methyl. On carbon number 5, I have a second methyl. So I have 2 methyl groups, one on carbon number 2, one on carbon number 5. Between letters and letters, you don't leave anything. It continues. Between numbers and letters, you put a dash. Between numbers and numbers, you put a comma. So 2,5-dimethylheptane. Let's look at the last one. So for this one, I could go straight across. I could do an L. I could do a backward L. Which one is the best method? This L. That gives me the longest chain of carbons, the most carbons. So let's box that and count how many carbons there are. So 1, 2, 3, 4, 5, 6, 7. And for this specific one, it doesn't matter whether you number it starting from here as carbon number 1 or here as carbon number 1, because no matter what you do, the branch is going to come off of carbon number 4. If I start here, it's 1, 2, 3, 4. If I start from here, it's 1, 2, 3, 4. So in this case, it doesn't matter. I'll start from the top. 1, 2, 3, 4, 5, 6, 7. Okay, so that is heptane. And then I have a branch. Here's my branch coming off of carbon number 4. and there are 2 carbons in that branch. 1, 2. So that would be F for 2, and it's a branch, so I call it ethyl. So if I put the whole name together, it would be 4-ethyl heptane. Okay, now let's do the opposite. So now we have the name. We're going to try to draw the structure. So we're going to start with 3-ethyl pentane. So what you look for first is the parent. So the parent is pent, right? It's pentane, so pent. That tells me 5 because of the pent. So I'm going to draw 5 carbons. 1, 2, 3, 4, 5. Next, the ane tells me they're all single bonds. Great. No, nothing to do about that. So I took care of the pentane part. Now, this is telling me I have a branch. The branch is an ethyl group, and that ethyl group is coming off of carbon number 3. So I'm going to look here. So I'm going to say 1, 2, 3. So this carbon has a branch coming off of it. So I'm going to go ahead and draw it a little bit farther out here so I have more room. 1, 2, 3, 4, 5. There's my pentane. And then carbon number 3, 1, 2, 3. So this carbon right here has a branch. The branch is an ethyl group. So F means 2 carbons. So that branch is made up of 2 carbons. 1, 2. That's it. Now I have to just fill in my hydrogens. So this one needs 3 hydrogens. This one needs 2. 1, 2, 3. This one needs 2. And this one needs 3 there. If I wanted to draw the stick structure because it's easier, I would say pent means 5. There are my 5 carbons. On carbon number 3, so 1, 2, 3 right here, I have an ethyl group. That means 2 carbons. There's 1, 2. That's what it looks like. Okay, next one. 4-ethyl 2-methyl octane. So I'll make this a little bit bigger so I have more room to draw. 4-ethyl 2-methyl octane. What do I look at first? I look at the octane part. Oct means 8. So I'm going to go ahead and draw 8 carbons. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Took care of the oct. Next, I look at the ending ane. That tells me that they're just all single bonds. Good. Next, I look at my branches. So my branches, I have 2 branches. One on carbon number 4, it's an ethyl group, and one on carbon number 2, which is a methyl group. So I'll just go in order. So 4-ethyl. So on carbon number 4, 1, 2, 3, 4. So this carbon, I have an ethyl group. So I'm going to put a line right there and put an ethyl group there. F means 2 carbons. So my group, my branch is 2 carbons. 1, 2. Next, I have on carbon number 2 a methyl group. So carbon number 2, 1, 2 right here. I have a methyl group. A methyl group is just 1 carbon. So I put 1 carbon there. And then just fill it up with hydrogens. It's going to be a lot of hydrogens there. 3 on this one, 3 on this one, 1 here, 2 on this carbon, 2 on this carbon, 3 on this one, 1 here, 2 here, 2, 2, and then 3 on the last one. Again, lots of drawings, so if you prefer, you can use the stick structure if you'd like. So if I wanted to do this as a stick structure, I have, let's move it right there. So what I would do is I would draw my octane. So there are my 8. On carbon number 4, I have an ethyl group. So 1, 2, 3, 4. This is carbon number 4. Ethyl group means 2 carbons. So there's 1, 2. And then on carbon number 2, I have a methyl group. So on carbon number 2, I have methyl. Methyl is 1 carbon. So there we go. Again, I'm going to show your vertices so you can see how I'm counting here. So these are my 8 carbons in my octane. And then on carbon number 4, I have 2 carbons. There's 1, 2. On carbon number 2, I have 1 carbon, which is my methyl. All right, last one. That one says 2, 3, 4 trimethyl heptane. So what do I start with? I start with the parent, which is hept. Hept means 7. So 1, 2, 3, 4, 5, 6, 7. Okay? Ane tells me no double bonds, no triple bonds, no ring, nothing special, just all single bonds. Next, looks like I have 3 different branches. One on carbon number 2, one on carbon number 3, one on carbon number 4, but they're actually not different. I misspoke there. They are all methyls. There's 3 methyl groups. Methyl means 1 carbon. So we find carbon number 2, which is right here, put a methyl group, which means 1 carbon. Find carbon number 3, which is right here, put a methyl group. Carbon number 4, put a methyl group. So again, I have heptane, a chain of 7 carbons, and then I have 3 methyl groups, 1 on carbon number 2, 1 on carbon number 3, 1 on carbon number 4. Lastly, I just put in hydrogens to give each carbon its 4 bonds. Hopefully yours looks a little bit neater. It's kind of hard to write with my stylus here. And there it is. If I want to draw the stick structure instead, here's what I would do. Heptane looks like this. There's my 7. Carbon number 2, there's a methyl group. Carbon number 3, there's a methyl group. Carbon number 4, methyl group. And that's it. The very last slide that I have here, which is also in your notes, is just a summary of what we've been doing. So to name an organic compound, what you do is you find the longest chain of carbons and decide what functional group it has. And so the longest chain of carbons, you give it meth, F, prop, put, and so on. And you end it with whatever the functional group ends with, like ane, ene, ine, ol. Then for the branches, you identify the carbon to which the branch is attached, write that number followed by a dash, count how many carbons are in your chain, name it appropriately, followed by YL, like methyl, ethyl, propyl. And then if there are 2 or more of the same branch, do di, tri, tetra, and so on. Or if you have different branches, you would do them in alphabetical order. So ethyl before methyl before propyl, and so on. All right, there's a worksheet that goes with this lesson. Try it and let me know if you have any questions. Hope you have a wonderful rest of your day.